Okay, we have come to the second and last example on curve sketching in Trigo function. Okay, in the previous example, we have dealt with cosine. But in this example, we're going to deal with sine, not just one oscillation, but rather two oscillations. Okay, but with the use of radian. And notice there's the use of the modular sign as well. Okay, so this is a very typical example as well. Let's take a look. You need to draw this particular sine graph. Okay, and this particular function. Notice this is of the form y equal mx plus c. There's no c here, there's an x over here. So obviously this must be a straight line. State for this particular range itself, what are the number of solutions for these two particular intersection? Okay, now let's get started. First thing, I'm going to draw the very first one. Okay, please do a check. The number of cycle is 2 cycle over 2 pi. So in one cycle, it must finish off in 1 pi. But take note, we are not going to draw up to pi. We're going to draw up to 2 pi. But why do I indicate this? It means for pi, I must need 4 equal segments. Okay, so let's get started. With pi, I need 4 equal intervals. Similarly, for 2 pi, I need another 4 equal intervals. It will be good you can fill in all the corresponding value, or if not, at least fill in the midway point. Okay, this should be good enough. Take note, our first cycle will end at pi. Okay? Now, take note, the next thing we're going to observe is the amplitude is going to be 2, so it's going to oscillate between 2 and negative 2. And we are ready to draw our very first one. Alright, remember, we are supposed to do our dotting before we join the dots together. Sine curve starts from 0. Alright? It will go up, back to 0, oscillate to negative 2, back to 0. This is your first cycle. Then, continue to oscillate up, come down, go down to negative 2, back to the original 0, and once you have seen all the dots, let's join them all together. Lovely. But take note, the graph that we have just drawn is for 2 sine 2x. But what are we required? The modulus of 2 sine 2x, meaning whatever is negative, you are supposed to make it positive. We do not want the negative portion. So, if you can, just erase and make it dotted line. Alright? Of course, it's very easy for me to do so. Now, this whole portion from negative 2, it will become positive 2. Similarly, negative 2 becomes positive 2. And it looks like 4 mountains. And there you have it. We are done for y is equal to modulus of 2 sine 2x. Now comes the complicated one. This is the easiest, even though it looks complicated. Y is equal to x over pi. On first glance, it looks very difficult. But mind you, drawing a straight line, how many points do we need? 3. So you just have to construct a simple table. Alright, with 3 points inside. Choose 3 convenient points. I will choose 0. Definitely, I'll choose the M point. You may want to choose another point that's in the middle. Okay, for your x-axis. When it's 0, you substitute inside, obviously it's 0. When it's pi, you substitute inside, you will get 1. When it's 2 pi, you substitute inside, you notice you will get 2. So we are going to plot this point down again. Okay, I'm going to use a different color now. So now, 0, 0. When it's pi, it's 1. Okay, it's at the midway point, 1. When it's 2 pi, it's 2. Now, your job is very simple. Join these 3 points together because it's a straight line. Lovely. We are done for the sketching part. Actually, part A and B is even easier. Just use your common sense and start to think about how many solutions do you think part A would have. Okay, this equation looks different from this one. But take note, because it's the intersection and we're making use of the concept of simultaneous equation, the number of solutions must come from the intersection. When you equate this particular equation to this equation, you can do a cross multiplication of pi from here to here. That's why 2 pi sine 2x is equal to x. It's as good as telling me these two equations are equated together. Alright, now count. How many intersection points are there? Let's count together. Okay, for the green line as well as the purple curve, which is the straight line as well as this sine curve that we have drawn. 1, 2, 3, 4, 5, 6, 7. There are total of 7 points, meaning there must be 7 solutions. Similarly, the second one, it doesn't have modulus, meaning you will not include these 2 mountains on over here, but rather you must include the dotted line over here because we are not making use of modulus. Then again, what happened to the 2 over here? Because when it's equated to 0, these 2 can be transferred over here as well. So it's telling me you are still solving for simultaneous equation by the use of the number of intersection points, but without the modulus here. So we do not include the intersection made with these 2 mountains over here. So if we exclude these 2 parts, you notice there's only 1, 2, 3, 4. 4 solutions. So please write down 4 solutions. And there you have it. We are done with the revision of curve sketching for Trigo function. Okay? And now, I really hope you can try this question. Give it a try. And tell me if you can find the number of solutions for this particular 2 graphs that you're going to draw for me. Alright? Similar question. On the same diagram, sketch y is equal to sine x and y is equal to modulus of cosine x. Sine 2x, modulus of for this particular interval. Okay? Now, state the number of solutions for simple as that. In one graph, you have to draw both the sine and cosine x. Give it a try. I believe you can do it within 5 minutes. And if you are able to tell me that the number of solutions is equal to 4, well done. Give yourself a round of applause. Okay?